Right, well, we'll start it again. So I'm gonna make, out of all these assignments that I give you, I'm going to make like a final exam of this unit, just to see. That I'll collect, and what I wanna do is I wanna see what you guys are able to do. You know, like, I've been giving you all these assignments and I haven't been collecting them because I'm using them now just for you guys to practice. So I don't know what level everybody is as far as understanding a document. So from now on, I'd like you guys try not to work as a group or with somebody and answering them on some of them. You know, if you went through them all and you can't get the answers, then work with somebody. But remember, when you're gonna be in this field, you're not gonna be with anybody holding your hand and telling you, no, that's not how you do it, this is how you do it, or this is how this works, or that's how it works. But I don't mind the team building. That works good, you know, when you're able to bounce off of somebody, because someone might know something you didn't know, or vice versa, and they help you out, you know, so you're learning that way too, so that's good. So there's a couple of things on here that I think there was one question that me and Corey were talking about, that the second one here, but we'll take a look at it anyways. Number one says, what key sequence is required to enter a diagnostic mode? So here's the diagram. And to enter diagnostic, it's cancel, cancel, and then start. Now, this has to be done in a time sequence, okay? Cancel 2 times and start within 5 seconds. That's all 3 buttons. So 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000, cancel, cancel, start. Why do they do something like that? Why are they making you press cancel, cancel, start? Why can't they just have one button take you right into diagnostics? Yeah, like customers go into diagnostics, and in some cases, diagnostics allows you to make changes on the temperature of the oven or other things, and the customer could screw things up by going into diagnostics. So all these manufacturers on I would say 99% of all these machines with computer controls have some sort of diagnostics built into them, but that is for the technician to use to troubleshoot it. The customer doesn't need to go in there. So they make it difficult enough for a customer not to accidentally. What's the odds of someone pressing cancel twice and start within 5 seconds? Now, you know, Eves, you had that BMW washer that wouldn't go into diagnostics. We found out the control board had an issue. It wasn't going in. Changing the board fixed it. So, you know, that's something you learn. So if you ever run in a washer and you can't get into diagnostics, but that's what the instructions say, there's got to be something wrong with the board. Okay? So let's just jump to this other question real quick, because we're in the same section here, which is, what does TST mean? What information does the first diagnostic screen display? And it tells you here, oops, this one here. Touchscreen's not working too good for me. 1 second, I'll just get the mouse. So here is that you're gonna see TST, and that's probably abbreviated for the word test. And it won't actually say TST, it'll look like TST, but some of them, they don't actually show you the full words. They use just like the number 8, and they use different parts of that number 8 to come up with the answer. So that's the answer to number 4, was that you're in the test mode, okay? So any questions on those two before I go on with the rest of them? No? Okay, that was easy. The next, let me just close this one here altogether. Oh, probably wants me to save it, and I'll save that, sorry. Okay, why should diagnostic mode only be entered when the oven is cool? Now, like I said, I'm trying to use ChatGPT to help come up with things that I might not think about. So I give it like things, I want this, I want to ask questions about this, and I just write portions of the question out, and I let ChatGPT write the question. So you were gonna add to that?
Yeah, well, I'm gonna answer the question.
Go ahead.
Well, for safety reasons, I mean, why you should put it, why it should be cold. You know, not damage any the elements.
So I don't think it would do it, that's what the answer key said. But if you're gonna go into diagnostics and you wanna check temperature or certain operations of things, if the oven's hot, you might not know what's working and not working. Like if a customer tells you the bake element wasn't working and the oven was hot,
You will have false.
and you try to go into a diagnostics and tell the bake to come on, the oven's hot already. Yes, sir?
You will have false positives.
Yes. So, that wasn't a great question though, but I still left it in there. Okay, so what happens to any active cooking operation when diagnostic mode is entered?
Stop.
It cancels everything.
Cancel.
Now, some stoves, when you have a freestanding range with a stove with a cooktop, you know, sometimes when you go into self-clean will lock the top out or lock other features out, like on a wall oven, a double wall oven. If you turn one of those ovens on in self-clean, you cannot use the other oven for a bake cycle.
Everything is off.
It'll lock it out because of the amount of heat and everything that's already in there. They don't want you to use both ovens simultaneously like that. Yes, you can use both ovens for baking or broiling or whatever, but once you turn one of them on self-clean, the other oven usually becomes inoperative. Okay? Number 5, what information can be viewed on the second and third diagnostic screen? So let's see if we can go back to here. Second and third diagnostic screen, you're gonna get this and this. Oven sensor temperature. What does that mean?
The temperature is, it's just the temperature in the oven.
Okay, so it's telling you what the temperature of the oven is.
Yes.
Okay, so if I was to test right now, roughly what would it read?
Room temperature.
0.
71, 74.
74, right? My hair touched the screen. So it would tell you the temperature. So this temperature probe, and I've talked about these before, inside the oven sensors are called thermistors. Now you guys, especially the ones that are new, thermistors is in a majority of our appliances. Our dryers, our washers, our dishwashers, our refrigerators, our stoves. Okay, you won't find them, oh, dishwashers have them too, if I didn't say dishwashers. Anything that heats or cools, that we have to have a way to control the temperature, and how does the board know what the temperature is? So this oven sensor is going to give you a specific reading based on the temperature. Okay, what is this here? Third, 00 through 30, user cooking offset. What the heck is that? Anybody got an answer for that?
0 to 30.
Yeah, but what does it mean? What does it tell you?
Maybe the type of cookware
No.
The length of time from 0 to
or
30.
the personality of the machine.
Did you guys read this?
Oh.
It says temperature adjustment. Press bake for 5 seconds. The current offset, if any, is shown as 00. I'll explain to you in a minute what that means. I just want you to see that. So, customer calls you out and says, hey, you know, I was cooking cookies the other day and I had the oven at 325 like the instructions. It said cook for 10 minutes. And in 8 minutes I smelled like the cookies were burning. So what does it sound like already? What I told you or what the customer said, what does that give you an indication of?
Yeah, it's too hot.
It's too hot, right?
Yeah.
So as a technician, what would you do?
Control the temperature.
Well, we would do what? We check the temperature, first of all. And a lot of our Klein meters have a little plug that plugs into it with a wire, and you can stick the wire in the oven, and it tells you what the temperature of the oven is. The same way the probe in the oven tells the control board. But first you want to see, okay, I'm going to put it at the temperature they said, and I'm going to check the temperature. So if the customer said 325, I'm going to say 325 and bake, and I'm going to check the temperature. First, what if you checked the temperature and it said 327?
It's fine.
It's pretty good. Now, because the thing is now, we have to understand how the oven works. And when you guys get into stoves, one of the things is customers will often complain about cooking results in the oven. And sometimes it's not the oven. Sometimes it's the pans that they use. It's if they put one pan over another.
Yeah.
When you bake, the heat comes from the bottom, and the bottom pan is going to keep the heat from hitting the bottom of the upper pan. So the top of the cookies will cook here, but the bottom of the cookies won't. And these will overcook before this gets cooked. But then the bottom one will get very, very hot and burn the bottom before the top cooks. So you're supposed to stagger them so that we get proper airflow. You know, on some of the stoves, they have like the coil burner, the old school burner, not the glass top. And when you work on the stove, one of the things I tell you is check the oven vent. And why am I telling you check the oven vent? Just so you know there's a vent there?
The air was.
No. A lot of times the oven vent is right where the left rear burner is. You have 4 burners, and there's an oven vent on the left one, and it comes through the hole of the pan and lets the heat out of the oven. When we cook in an oven, we don't want the oven to be totally sealed. We want airflow and air circulation so that everything cooks evenly, okay? Now, if a customer takes the burner out and takes aluminum foil and puts it in the pan and puts the pan back and plugs the burner in, what happens to the hole in the middle? It's blocked. So now you cause uneven temperatures in your oven and you get poor cooking results.
Yeah.
That's why I'm telling you about the vent, because it's important for proper cooking. Okay? So what if the temperature is off? When we do a temperature test, I was taught you take 6 temperature readings. And when you turn the oven on, and let's say I turn it to 350, the oven's cold. The oven's gonna go like this, and when it hits 350, the elements turn off. But are the elements cold immediately?
No.
No, if you take a frying pan off the stove,
Still
and I hold it for 2 minutes and say, here, touch the pan, would you
No.
touch it?
No.
No, because it's still hot, right?
Very hot.
So when the elements are, the power's turned off to the element, they're still radiating heat. So even though it's set to 350, it way overshoots that 350. It could go as high as 370 when it overshoots, okay? But now when the oven's off, the temperature is going to start to drop because the oven vent is allowing some of that heat to escape. We need to turn the elements back on. So as the temperature is dropping and gets below 350, it comes back on, and now it cycles above and below that 350. So you're supposed to take 6 readings and take the average of the 6, but we do not take the first off. What I mean by that is like it comes on and it goes way over the temperature and it's off. Now it drops. I'm going to take the temperature when it comes on, goes off, comes on, goes off, comes on, and goes off. I add them together and divide by 6, and you'll have an average temperature. And if it's within 5 or 7 degrees, it's okay. But if you got 20, 30, or 40 degrees off, there is an adjustment built in. And why am I explaining all this? Is because 0, 0 means it's set at 0 from the factory. And what I mean by that is, if I told you, oh wow, I checked the oven temperature and the oven temperature was 370, but I was set at 350, but my average was 370. What does that mean? Too hot, right? So I can adjust 30 degrees higher or lower than the set point. 0, 0 means it's not been adjusted at all from the factory. It's set from the factory. And I have a video on YouTube. It's a real short video, a 5-minute video. And while we were in COVID, I was trying to think of videos I could make. So I made a video on how to get into the oven control and calibrate it. So if I'm telling you my temperature is 20 degrees too hot, what do I need to do? I can go 30 above or 30 below. I go below how far? 20 degrees. So I'm going to do the adjustment and go to minus 20, and it's still not going to change the screen. It's still going to say 350, 325, but it's going to cycle at 20 degrees colder. Once you set that, you'll never have to adjust it again unless something goes wrong, but you can only adjust it 30 degrees either way. If you usually get a 20 or 30 degree difference, the first thing I recommend is changing the oven sensor if the elements are working okay. Because what happens is when you self-clean an oven, that temperature is so hot, it causes some of these sensors to screw up and they don't work right. So usually, if it's about 10, 12 degrees, I would adjust it. And a lot of these ovens can only adjust in 5-degree increments, above 5, 10, 20, 30, or whatever, or below. So that the 0, 0, the offset is meant, if I go in there and I saw the temperature was off, and I got 370 at 350, and I already saw, I go in there and I see -20 instead of 0, 0, what's that telling me?
Somebody's adjusted it.
Somebody went in there and already calibrated it, and now it's 20 degrees off again.
Yeah.
Time to change the sensor. But you change the sensor, what do you gotta do? Go back to 0, 0, and then calibrate it. Then you wanna test it to make sure it's working right. So in other words, remove the -20 that someone had put in there, go back to 0, 0, put a new oven sensor in there, and then go back into diagnostics, go to this step here where it's the user cooking offset, and that's what you do that for. Okay, so everybody on stove should have at least done it one time. And if you haven't done it yet, you gotta do it, okay? I want you to learn how to check the temperature as well as adjust it and see what happens. Make an adjustment, go 20, 30 degrees higher or lower, and then do that same 6 temperature test again, and see how it works. You know, always put it back to 0 when you're done, but learn to use it, okay? And there's a very short video, I think the video is 5-10 minutes long at the most, and I just videoed, this is how you get into it, and that's only one model. Every manufacturer now has their own way to calibrate them, okay? Back in the day when you had a thermostat, you could turn a dial. They used to have the shaft that the knob went on, there's a hole in the shaft and there's a little screw in there, and you could get a little tiny screwdriver, like an eyeglass screwdriver, and you could turn the screw, but you had to hold the shaft and you could adjust it one way or the other. And that's how we calibrated the old mechanical kinds of thermostats before we went to this one. All right? But usually we say, listen, if that temperature's off, don't calibrate it. Because that's a mechanical device and it's already 20 degrees off.
So you want to change?
Even if you calibrate it, it's going bad, just change it. Don't get into adjustment, especially you're charging a customer for a service call and you adjust it, and 30 days or 60 days later, they call you back and says it's off again. Now you gotta go back a second time, and then you gotta order the thermostat, and then you gotta go back and fix it. So that's not a good thing.
Alright, boy.
So,
That's it for you, man.
anyways, that's what the cooking offset is, and that's how we use it. Now, what they did, instead of having, this is just in case you guys run into it, instead of having a little screw down the shaft of the thermostat to adjust the oven temperature, then they said, well, we're not gonna make the thermostat adjustable. We're gonna take the knob off, and on the back of the knob, there's 2 screws, and you can turn the back part of the knob that says 350 or 200, and you can turn it a little bit and line it back up and tighten it up so you adjust the knob and not the thermostat. But again, usually an adjustment requires a replacement, okay? But if it is off slightly, you know, it's under warranty and something, it's not sort of brand new unit, you can make a slight adjustment, the customer feels like you've taken care of that, all right? So let's go to the, what happens to, oh no, we already did that, we already did number 4. What information can be viewed on the no, we did that one too.
It's number 6, I think.
What does display CLR indicate in the diagnostic mode? Clear, to clear it out, to get out of whatever you're setting, okay? It's almost like canceling. What does the F number mean?
Old or error code.
Yes, F just stands for failure, okay? F3, this goes back into the early 90s, late 80s. I don't remember how long ago the first electronic controlled ovens came out, but F3 was a very common problem, and that meant your oven sensor is bad. But what happens when we got double ovens?
Double F.
What?
Double F.
Double L?
F.
Well, they started doing like this. F1,
F2.
E1 or F1, E3. F1 would be the failure. E1 would be the error with that failure. Okay, like you could have a bad motor, but it could be a bad winding, or it could be a bad centrifugal switch. Not that has error codes for that, but as an example. But in a double oven, it'll probably say F3, E1, meaning the first oven, the top oven. And then F3, E2, meaning the sensor in the bottom oven's bad, because it's the same control board for both ovens. So sometimes you'll have an F error code separating between the upper and lower ovens. Okay? Next question. Let's go to here. Error code troubleshooting. What failure code causes an F1? So we got to go down here.
Internal board failure.
Okay, internal board failure. So the nice thing about this, they give you things to check and tell you, hey, if you get this code, these are the things you need to do to troubleshoot it out. Verify that it's the display match. If failure, unplug the range and disconnect power. A lot of times, if you get error codes, they'll tell you to disconnect the power and plug it back in and see if the error code repeats. Sometimes you'll have machines that will have an error built in them, especially washing machines. And you go to a customer's house and they tell you, oh, this is what it's doing. It's banging all around like the BMW washer. It's always banging, right? You go in there and the error code says something else, like motor. But the motor's running. Well, that error code might have been in there from 2 years ago, and a technician had already changed the motor, but the board doesn't know the motor was changed, so it stores that memory. So you as a technician, when you have error codes appear, sometimes you want to CLR, clear that error code, try to use the oven again, and see if that error comes back. If something's wrong, the error is going to repeat. But that lets you know whether it's a recent error or an error that's still there, or an error that may have been repaired a long time ago but not removed from the system memory. So sometimes unplugging the machine and plugging it back in resets the control board and the error's not there anymore. Sometimes the programming, they got it, the programming trips over itself and causes a problem. Okay? Next question. What is the first step when diagnosing a F3 oven sensor? Let's go to F3. Verify oven sensor diagnostic mode screen is room temperature, typically 59 degrees. Verify failure code. If failure code does not match, then continue. Okay? So they want you to do that. Now let's not just talk about it because I haven't read all these questions. You go over there and you think the oven sensor, F3, the oven sensor is bad. How do you approach testing that? Like, okay, the oven sensor is bad. You're just going to say, sir or ma'am, I'm going to order you an oven sensor. I'll be back and put an oven sensor on. You know these double ovens here that we have in the cabinet? Are they easy to take out?
No.
No, they're not.
Not at all.
So if I don't have to take that oven out to get to the sensor, what do I do?
Test it from the board.
From the board down.
Test it from the board. So you go there, and do you guys remember what the resistance value of the oven sensor be at room temperature? Do we have that on the
Yeah,
diagram?
50 to 90 degrees.
Like 1080.
Okay, is it on this chart here? I got all this text sheet here. Let me see if I can find it. Maybe it's up top.
Between 1,000 and 1,200. Is there?
Where is it at?
It's in the document.
First page, second page? I was trying to find it though.
Yeah, 1,000.
It's in there.
It's on the back page.
It's on this page.
Okay, page with the strip circuits. Okay, so it's here? Okay. Okay, 1,000 and 1,200. You're gonna see as low as 1050, 1,050. 1,200's a little high, but almost, it used to be all oven sensors read the same resistance. They used the same thermistor to do the oven temperature, okay? Now, a couple of years back, Frigidaire was here doing training, and the guy says, you know what? Our oven sensors now read 500 at room temperature, not 1,000. And they're like, well, why'd you do that? And the resistance value is usually about half what it would be on these here. And they said, well, testing from our engineers determined that the lower resistance value thermistors were more accurate in controlling the oven temperature, the cut-ins and the cut-outs, that we found out that they were more accurate, so we went to this new sensor. Now, if you didn't know that and I didn't tell you that, as a technician, you better make sure it's written on your tech sheet, because you're gonna go there and say it's supposed to be 1150, and I only got 500 ohms. And I think the sensor's bad when it's not. Now, what if you go to the control board and, Paul, there's one by the clock if you want. If you go to the control board and you want to check the sensor oven resistance value because you can't get behind it, but you go to the oven and you don't get a reading. You're not checking the board, you unplug it and you're touching the two wires that go to the sensor, what do you do? Well, continuity, ohms and continuity is the same test. But it's a good
Tell the
service.
customer to get a new stove.
Tell the customer to get a new stove.
We'll go down to the sensor itself.
Yeah, but it's back there in the oven.
Oh,
Now-
you touch the elements.
Well, a lot of the oven sensors have screws in the oven, and the oven sensor's low voltage, okay? It's only like 12 volts. So you could unscrew it, and if you're careful, you could pull the sensor out and get to the quick disconnect right there and ohm out the sensor from inside the oven where you cook the food. Okay? And you can replace the oven sensor that way. Some of the elements, back in the day, the element went bad in the wall oven, is you can pull it out. But what happens is you pull too fast or the wire's too short, you unplug the wire, guess what? The oven's got to come out. Back in the day, I don't know how many times I would pull the element out and the wire was burnt off. Well, you got to pull it out anyways to repair it. But remember, turn the power off before you do that. Okay? Safety wise, we don't do it while it's plugged in. But always give that a try. If you feel that the element's bad, sometimes when a bake or broil element goes bad, it blows up and it has like little melted bubbles on it. You'll see it like destroyed. And you say, oh yeah, I know that element's bad. You order a new element and come back. Try, if you can, to pull it forward and unplug the wires and plug it back in. I've always had, I don't know what they call those long things that like a surgeon will use. They lock. They're the hemostat. Are they hemostats or whatever? They're like tweezers, but real big and long, and they could lock.
They are hemo something. You're right on the thing we talked about. The hemo something.
Hemostat, isn't it?
Yeah.
Yeah, but they make them real long, but they're real thin, so you could stick them in the hole and possibly grab the wire and pull the wire out if it came off. I have a set of them at home in my toolbox, and they're this long, and I can use them to reach into a small opening and pull that wire out if I need to. That's what's good about those tools, okay? So that's it for that. Let's go to the next question.
Anyways, but was
Yes, sir.
page 2 on the F3? The answer.
I'm sorry?
You asked me the page, and I say page 2 on the F3.
Page,
The previous question.
okay, hold on a second. Page 2?
Yeah. F3.
Yeah, that's
Go to F3.
Yeah, I was reading
That's
that.
number 5.
I read the first, you're talking about this right here?
The
Number 5.
1,000, 1,200.
Oh, it's here. Oh, okay, thank you. No, what I was talking about when I was asking about the resistance is a lot of times, you guys remember the last stove that we've been working on? That I gave you another stove prior to this one that you had a tech sheet on. It had like a little chart, and it told you at room temperature, but at 350 degrees or at 500 degrees, and it gave you the different resistance of each part at different temperatures. Okay, so that's what I was looking for, but thank you. All right, so the next question. If the oven sensor measures 500 ohms, what does that indicate? So let's go to the chart here.
Is
And
a faulty one and need to be replaced?
it what?
Will be a faulty one and need to be replaced.
Okay, but where does it say it?
Number 4. Neutral.
Where?
500?
Yes.
From there.
No, but that's not the oven sensor, that's the latch
That,
motor, okay? So,
It says it on the same page that you were, page 2.
page 2,
Yeah.
stopped it right there, look at that.
Page 2, very famous.
Where does it say it on the page?
Down, page 2.
Well, no, it's supposed to be.
What's,
That answer, I don't think that answer's on the paper.
What should we looking at again?
the one that says if the sensor reads 500 ohms, what does
It's
that
just
mean?
shorted.
It's less, it needs to be changed.
It needs to be changed.
Yeah, it said it
Because-
needs to be changed, it's a shortage on.
Yeah, I was looking to see if it's written there, but if they're telling you at room temperature, it's supposed to read 1,000 ohms,
No more, yeah.
and you test it, you get 500, it's bad.
It's bad.
I seen that answer, I seen that question on the paper.
Yeah.
I highlighted it.
Okay, so the next question, Is- what mechanical problem could cause an F5 door latch error? so-
Don't switch, don't agree.
My little kid had
F5 door latch, so the question says, what could have failed?
It's a broken latch.
Door and switch, do not agree.
door switch, door lock.
Check the wires and the connections to it as well. Listen, wires don't go bad that often, even on ovens, okay? Usually it goes bad because the wire, the crimp, or the way they connect the connector on the wire wasn't done very well from the factory, and it runs hot every time you use the oven. Now you got some people that cook 3 or 4 times a day. You know, down here in Hialeah, we have a lot of food trucks. We call them roach coaches, right? I've gone to people's houses and they cook they got a pot this big on a burner this big, and they're cooking rice and beans and all these other things, and they're selling it to the guys that are driving the lunch trucks. That's what they put in their food. Now they have places in Hialeah, I've been there too, that sell all this food, but they have these people that are cooking food at home and selling it. But they're cooking all day on the stove, and that causes a lot of things to burn out because you're using it more than it was designed for, using it in a commercial setting. What do you do as a technician? You run into a customer's house and you realize it's 6 months old, but it looks like it's been to war and back, you know?
They're
And
using their own stove.
Yeah,
they're
you wanna
using-
ask what,
Yeah.
what are you using it for, and what are you doing with the stove?
But if they tell you they're cooking for lunch trucks, what do you tell them?
That's not commercialized,
It's not a commercial
stove.
You're using it improperly and the warranty is void.
No
Come
own
by
stove.
and tell me that, I'm gonna tell you about your business. Fix the stove.
Well, you know, the same thing, you go over there and the control board's bad, but there's cockroaches running all over the control board.
Sure.
So you got cockroaches that run all over the control board. What do you think will happen if you put a new board on this unit?
Same
Back to
Well,
the
it's
thing.
gonna be
same
right
thing.
there, it's gonna be right
Same
there.
thing.
They're going back to their home.
So our technicians would say, okay, ma'am, thank you, I'll go ahead and get the part you need, if they would leave because they don't wanna tell the customer you're not gonna fix it. They let the office deal with it. Or a lot of times if it's a third party, you let the warranty company or whatever, you got pictures and you verify it with the warranty company, you tell them, hey, I went to this customer's house, the control board's bad, but there's roaches all over it, and repairing it is going to just break again, and let the warranty company deal with the customer. Said, listen, we're not covering this repair because it's abused. You know, just like if someone's cooking on something that's for a home, but it's used commercially. So we don't want that to happen, okay? Next question. Oh, wait a minute. Number 5 said, what mechanical problem? We didn't answer that, did we?
The latch.
The latch, door and,
The latch failure.
door and switch, do not agree.
Got a door switch,
Yeah, the latch.
we answered it.
Warp and misalignment. So the door can be warped. I've been to customers' houses where customer has a regular freestanding range, you know, in the kitchen, and they have young kids, and the young kid opens up the door and stands on the door to get in an upper cabinet. What happens to the door? Now, instead of the door open like this, the door's like, you know, you open the door, it's supposed to sit level,
Latches.
and now it's hanging down like this. Dishwashers too. When you see them hinges bent like that, they wouldn't bend just by the door doing opening and closing. Now I have seen dishwasher door hinges bend because one of the springs broke And by accident, the customer opened it and thought the spring would hold the door, and the door came down and bent itself because the door itself was so heavy, so that can't happen. Okay, GE used to have these two rollers, and they had a wire that crisscrossed across like this and then went to the door, and when you opened it, the springs would stretch the rollers back and forth. That rope would break, and then the door would drop and cause bent hinges. But if the door is not aligned, that would happen. Now again, back in the days when we self-clean, they didn't leave the glass open. They actually had a metal shield in the door, and when you open the door, you had to slide these two metal things up, and you would have a metal shield inside the door. So there'd still be glass here, it'd be behind the glass, but that would help reflect the heat from coming out of the oven. Now you guys probably will never ever see those, but those are ones that were out there when I was working on equipment, okay? So let's go to the next question. What voltage is supplied to the bake and broil ovens?
240,
220 to
L1,
240.
L2.
Yeah, line 1 and line 2. So if I want a lower temperature, do they drop the voltage to the elements?
No.
I sort of told you how they control temperature, right?
Yes, it's off.
They cycle. This air conditioner works the same way. You put the AC to a specific temperature and it runs, gets a little bit colder than that temperature and shuts off, and then it gets warm in here until thermostat turns it back on and keeps an average temperature, okay? So, what component protects the oven from overheating?
Temperature fuse.
Thermal fuse.
Thermal fuse?
Yes.
Thermal fuse, yeah.
Right here. Now, thermal fuse is in series with what? The broil element. Does the bake element go bad if the thermal fuse, or does not work if the thermal fuse goes bad?
No.
Which
You
one?
know, you should know.
The bake element.
On top, no, it says.
Look, power comes in line 1 here,
Mm.
goes through the bake relay, goes to the bake element, and then goes down to the DLB, double line brake relay, which is line 2, and goes out. But broil goes this way. Okay. So it only affects the broil oven. Will the oven bake?
Yes.
Yes,
Yes. But,
it won't self-clean.
well, it might self-clean.
Yeah.
It won't do a great job at
Yeah.
it. But going back to the bake, a lot of ovens, when they bake, they use both bake and broil in it. Now, the mechanical oven, sometimes when you went into bake, would put 120 volts to the broil and 240 to the bake, because we didn't want to burn the cakes or the cookies that we're baking. But we wanted an element on top to add some heat so the oven has more even heating. Okay? But in an oven like this, there is no way to change the voltage. You got line 1 and line 2 on both sides. But what they do is they'll cycle the bake element on for 70% of the time, and 30% of the time the broil is on. So the bake would come on and heat up, and then they would shut the bake off, turn on the broil. The broil would be on for 30 seconds, a minute, and shut back off and go back to the bake. And what it's trying to do is trying to even out the oven temperature that way. So if the thermal fuse went bad and they don't use broil that often and they don't know it, they're going to complain of baking results. Who would, if I told you my oven is not baking properly, would you even think to check the thermal fuse on the broil element? But that is a thing that needs to be done. Is there a chart on this? I haven't really looked at the chart that tells you, like in bake, what is energized and not? Probably not. This don't have it, but a lot of manufacturers will use both the bake and the broil, but the broil does not stay on that long. It's only on for a little bit, shut right off to try to even out the heat.
Does it go back to broil though? Like as far as
Well, if you
the
wanted
heat
broil-
temperature at the bottom?
No,
The temperature's on top. The broil is mostly the top, isn't it?
yeah, but the broil isn't on for that long. So that the bake is on, the bake is on, the bake is on, bake shuts off, broil comes on, broil shuts off, bake, broil, bake, and back and forth. Yes, sir.
Like 3 to 1.
What?
Like 3 to 1.
I don't know what the average is, but they do alternate back and forth. And the last stove that I gave you the diagram for had a chart, and we did talk about the alternating of the broil element in that lecture. Yes, sir.
Do they put the thermal fuse there because most people tend to put the food near the broil element, like naturally?
No, I think the thermal fuse is because it's at the top of the oven, and like the one you just worked on, what was on the other side of the top of the oven? All your computer boards.
Yeah.
And if your broil is exceeding a specific temperature, that excess heat could damage controls. So as a safety, we shut it down. Okay? I'm almost positive that's what it is. I could be wrong, but that's usually what it's for. Okay? What relay on the control board energizes the bake element? So if we go
K4 big relay.
Control
Back-
2-7.
relay,
2-7.
Control 2-7.
K4.
K4.
Now, technically, K4 and K5.
Mhm.
Because if I don't close K5, I don't have line 2 and the element won't work. Okay? So that is one of the answers. I would say K4 and K5, because if you just turn on K4, none of the elements would work.
Yeah, that's something I'm thinking, yeah.
Okay? Any questions on that? Nope. What relay controls a broil element?
Control
400
2-1.
and 3400.
K3 and K5. I would put both.
I did, I put both in there.
Oh, you put it-
That's why I put the numbers.
With a big.
Yeah, I put the numbers.
Now let me ask you guys a question. If it broils and it don't bake, do I need to test this relay? If it broils and don't bake, or bakes but don't broil?
Yes, cause that's line 2.
Yeah, but if one of them
Yeah,
work and the other one doesn't, what does that mean about line 2? It's good.
Yeah, it's working. It's working.
So what I mean, like, is if this element works but this one don't, or this one works and this one don't,
It's still
I'm
going.
not gonna, they both have to use this one.
Yeah,
They have individual ones here. Why do they have individual ones here but a double one here?
The 61.
Double one is for safety, because remember I go back, 1983 I was learning appliances, and I was working for Sears. They didn't have control boards back then, but they came out after a couple of years. But what happened is, they didn't have this line 2 relay here. So they had 2 relays, one for bake and one for broil, and then from here, both of them went to line 2, which meant one side of the heating element had power all the time. And people were pulling the element out like I told you, and not unplugging it, and they would get it out, and they'd grab that wire and get electrocuted.
Wow.
So always unplug the machine for safety before you stick your hands on there. But electrical code, I don't know if it's UL or whatever, the underwriter laboratories who determine safety in electronics and electrical equipment, they said you gotta put a second relay on the other side of the element so that there's no power at the element when the oven's off. Now, it doesn't mean a relay can't be stuck, but why do we use different ones? Not just to turn on bake and broil, but this relay here is the one that cycles on and off when we're turning the element on and off for temperature.
Lower wattage.
I'm sorry?
Lower wattage. I can't say.
Not for low wattage, it's just turning the element on and off. Remember I said when we want to calibrate the oven, we wanted to see it shut off and then come back on and shut off and come back on. Well, that's the relay that's turning on and off. This relay stays closed. This relay doesn't cycle.
So that relay usually go bad?
Which one?
The double relay.
Oh, that goes bad a lot on some of these ovens. A lot. But usually when that one goes bad, both elements don't work.
Okay, got it.
So what's the odds of both of these relays failing? Most likely it's just this relay's bad if both elements don't work.
So
Okay,
you can pretty much backtrack from if one of them is not working and just go back to your side and test that one. If there's nothing there, then you know one of the K4 is bad. If you go to the K3 and that one has their voltage, then you know it's not that one, it's the K4 that's bad.
That's only if one
If
element's
one is
not
bad,
working and the other
it's-
one's
But they
working.
can still run through.
But if one's working and one's not, we know it's not this.
It's not that because that's still,
Okay, that
you
means,
still get
okay, I
power.
was just
from
gonna ask that
everything.
question, so that means K5 is okay.
Yeah.
Exactly.
If both of them don't work, then you know
Then
your
K5
K5 is the one that's completely
Most
bad.
likely.
Most
And,
likely.
and then you could just put a jumper on these 2 red wires
And
here
bypass it.
and test it to see if
So
the
when
oven
we
works.
test that oven back there, it was just a switch, it wasn't turning, okay, never mind.
Okay? So now you guys understanding like operation and cycles of the machine? Okay. Let's go to, what's the wattage rating of both the bake and broil element?
10 minus
24 and 34.
Yeah, you're right.
K.
2400 and 3400. What is wattage? If I ask you what the wattage is, what am I actually asking you for?
The way.
It's power.
We know it's power.
Okay, but what does power
I know
mean?
what you're messing with.
What does power mean?
Like the intensity of the
He's
electric.
almost there. Not.
It,
the voltage.
okay, you guys all learn Ohm's law and Watt's law when you first start. It's one of the things you learn in the first couple of chapters, okay? And when you're testing an oven, the wattage is the power output. And I'm gonna bring up something about the wattage and how it sort of relates to this, is that if I had a 50-watt light bulb and I had a 100-watt light bulb, which one's brighter? 100-watt light bulb. So the wattage is telling me how bright the bulb is. If I have wattage on a speaker, I had a 50 watts to this speaker, 100 watts to this speaker, what am I expecting different?
The voltage,
How loud the 100 watt is more than the 50 watt. Okay? If I have a 50 watt motor, a 100 watt motor, how much power can that motor handle? How much strength does that motor have? Wattage, they rate in horsepower. Okay? Horsepower is wattage. And you learn that in basic electricity, but I don't really teach it too much. So what am I talking about? Just so you understand something. I went to a customer's house and they had a glass top stove. And you turn the burner on the top of the stove and you put it on high, what do you see?
Red.
Red or orangish glow of that element, right? Well, I had a lady down the street or a block over that's friends with this customer, and she says, you know, I have the same exact stove in my house, but it doesn't glow red like hers. What's wrong?
There's a balance.
The wiring at home. The wiring.
Yeah, some wire is not hooked right.
Well, what do you mean the wiring at home?
It's not wired properly for the
The line one.
is the switch.
Outside your house, whether you live in a home that has a telephone pole with the power lines, or you live in a newer neighborhood that's got those metal boxes outside by the sidewalk, you know, those, they have transformers in there. So the FPL, the power company, goes to those transformers and they're the ones that feed power to your home. Now, in our shop here, some of the outlets read 220, 240, but some read 208. And that's because when this room that we're in now was built, it was an addition to the building. This was not built when the school was built. They built this room. They added the room for me to have a separate classroom. But they didn't have enough power to feed this room. So they had to put a transformer in my office that feeds this room. But that transformer came off the power already in the room, which was like 220, 240. And you always have a little drop of power when you go from one side of a transformer to the other. It's supposed to be an equal passive rate, but it's not 100% that way. So you get a voltage drop. Well, what if the transformer at this lady's house 2 blocks over is giving her 208 and this lady's got 220, or this lady's got 220 and this one has 240? The same stove, if the element's going to be brighter or not, depending on the voltage coming to the element. And there's nothing wrong with the element. If all 4 of her elements are doing the same thing, well, man, the first thing we need to know is how much power that element is producing. And in order to do it, we need to know the voltage. So we have the voltage, the amperage, and the wattage. Wattage is P is power equals I times E, which is current and voltage. So you take the current and the voltage 208, you measure the current going through the wire, and you multiply them, and you get the actual wattage output. So if you had 208 times 10 amps, that would be what? 2080, right? P equals I times E. Power, current, and volts.
I want to ask a question.
Yes,
Could
sir.
the switch, something wrong with the switch, not giving enough juice to that element?
Well, let's go to here.
Well, because the switch could be bad.
Okay, but this right here is a surface element, right?
Right.
How could the switch be bad? What would be bad in the switch?
Well, it's increased voltage.
But this switch here, this is your infinite switch here and here, okay? It's on both sides of the element. There's nothing there that raises or lowers the voltage.
But that's a problem that you had to contact FPNL about.
Well, you need to know the voltage, but going back to what he was saying, is that when you go from high on your burner and we go to medium or low, are we going from 240 to 120 volts on medium?
No.
So then how are we getting medium? The
No,
same
you-
way we do the other.
Okay.
Go ahead.
I was just gonna say that because it's dealing with the wattage, you bringing it down.
We're not dealing with the wattage. Wait, let me explain something. If this is 3,000 watts, high, medium, and low, it's 3,000 watts. The difference on high, we give it voltage 100% of the time. Voltage is always going to that element.
That's what I was trying to get.
If I put it on number 5, which is like the middle, the element's on for 20 seconds, it's off for 20 seconds. It's on for 20.
It's a pulsing.
We're turning the element on and off, just like the oven. We're cycling it to get a lower temperature. But it still has the same voltage. Now, he is partially right. The switch could be bad because the contacts, the points could be burnt. And if they're burnt, they're not making a good connection, which causes a current flow problem and a voltage drop to your element, and you're not getting the power. But it's very rare. Yes, sir.
It could be behind the stove too, with the line 1 connection and the line 2. That could be burnt out.
That's possible.
Yeah, but
Just
at
like
that
the
point,
stove-
at that point you
like
can
the
have.
stove we had back there with the air cold first one, remember? The power source.
Mm-hmm.
It's not getting, like you say, the 240.
But the point I'm trying to get in that is, one of the tests I make you do on stoves is I have you put your voltmeter where the element is, and I want you to put it on high and watch what the element does. Put an amp probe on the wire. Watch it cycle on and off on different settings and see what the percentage of time that the element's on and the percentage of time the element's off to see how it functions. Yes, sir.
So with that there, going off a little bit, because we're going to gas, how would that work with the gas though?
Recycle the burner on and off, but the burners can't go on and off, can it?
No, no, you gotta control it with the flame.
So we change the flame height.
Okay, gotcha.
It'd be like a sprinkler. You put the sprinkler on high and it shoots over the whole yard,
Okay.
but you close the valve a little and then the sprinkler's not as big.
Gotcha.
But the flame is still just as hot,
Yeah, because it's the
but
the
it's
regular.
a
We got the
smaller
regulars.
flame.
So it's the regulator in the gas.
That's what, that, if you notice like that expensive stove we have over there is called dual fuel.
Yeah.
Dual fuel is gas
Propane
cooking
and natural
on the
gas.
top, an electric oven. Why did they do that?
Oven is it's easier to control the heating in the oven.
It's easier to control or maintain the temperature in the oven. You get better cooking results with electric elements. But why don't we use electric on the top?
Because the gas will cook better and faster too. It's easy to control.
It
the
heats
gas.
up faster with the gas cooking. You have instant heat where the element has to raise up. And when it cycles off, it's got to cool down a little bit and then it comes on and then it's got to take a few seconds to raise up temperature. And it uses more energy if it's not gas and it's electric. So it's more energy efficient if it's dual fuel, but it gives advantages, and that's the reason why they made that stove. It was off subject here, but let's go on to part 4. Circuit diagnosis. Using the strip circuit table on the diagram, what resistance should the bake element measure? So they're telling you here, what resistance should the bake element measure? This is a surface element.
10 to 20. 10 to 40.
40.
Oh.
Wait a minute, but this,
It shows you in the bottom. Scroll down.
it says in the box?
Right there.
That's it. I highlighted it.
Bake element, here we go. 10 to 40 ohms. And the broil is also 10 to 40 ohms.
Yeah,
So if they were both 40 ohms, what's the wattage? Are they different wattages? No, because if the voltage is the same coming in and the resistance are identical, the output power is identical. Now Corey does a lot of like stereos and stuff in cars, if I wanna get more power out of my speaker, most speakers are 8 ohm speakers when you buy them.
You can drop it down to 4.
You drop it to 4, even go down as low as 2.
Yeah, all zero.
And if I go from an 8 ohm to a 4 ohm,
Deeper bass.
well, I can have more electrical current flowing through. Remember, ohms are like kinks in a hose. I went from 8 kinks to 4 kinks or 2 kinks. The flow of water through that hose would go faster with less kinks. And the current flow is the same thing. Okay? So, next question. If the bake element is OL, what does that mean? Yeah, I don't know why it typed the word open, but that just means that the element's bad.
Yeah.
Okay, we're supposed to read 30 ohms, and then it's supposed to be 30 ohms. If the thermal fuse is open, what symptom would the oven likely show?
System shuts down until temperature normalize.
It's gonna be off.
Well, what symptom would show? In other words, if the thermal fuse went bad,
The boiler
It's so
breaks.
zero.
what would the customer see to call you out?
Not
The
working,
boil-
this will
Now you-
not working.
It would exceed the temperature.
The what?
Exceed.
Kamar, you got an answer, or you just hold your hand up?
I haven't, but.
Okay. So, if the thermal fuse went bad, we'd have no broil, or we'd have uneven baking.
No working stove.
Those are the symptoms. That's what I'm saying. It's like we talked about earlier. But when they're saying symptoms, those are the things that customers would say. You know, customer can sometimes guide you to the problem if you communicate to them
Yeah.
enough.
Yeah,
Remember, when you go see a doctor and they do a temperature test and your blood pressure and they take your blood and all this other stuff, if something's wrong, the doctor asks you, oh, what brings you in today? Oh man, my back really hurts. Every time I do this, you know, it hurts. The doctor just says, well, don't do that anymore, right? You know? So, no, but the doctor has to ask you questions to try to find out what's wrong with you.
Yeah. Why you coming?
You as a technician are a doctor for the appliance and you need to communicate to the customer and ask them a few questions. A lot of times you get there and the neighbor was the one that let you in and the customer doesn't know.
But what
Okay.
about the customer when you speak Spanish?
Then you speak in Spanish.
Well, I back in the day, we had the Mario boat lift where a lot of
80s.
Cubans came from Cuba. And so when I went to the house, the abuelo was there, and I only knew 2 words in Spanish.
Hold on.
Cafe and hueco, which was hole. And I was trying to explain to the customer the vent on the dryer was blocked. And I'm pointing to it, and the customer go, hueco. And I'm like, what are you talking about, hueco? What the heck is that? I used to have to call on the phone, landline, to the office, get someone to speak Spanish,
Yeah.
talk to the
Translate it.
customer, find out what's wrong, tell me what the customer said. Then I would check the machine and had to call back to the office and get them to translate to the customer what I found.
Yeah.
Now I
But now
speak
you got
Spanish.
apps though. Now you got
Yeah.
apps.
Now I speak Spanish.
Now you got apps too.
I learned
You
to
can
speak
just talk
Spanish.
to it now.
Okay. If the oven light circuit measures 0 to 40 ohms, what does this indicate? What? Oven light circuit?
That means it's working.
You gotta go right
It
there.
has low resistance.
It means it's working.
Yeah, being normal.
Does not work.
But 0 ohms is not a normal reading.
They never have zero.
That's an error.
They never have zero.
Because if the light bulb read 0 ohms, what does 0 ohms indicate? A short circuit.
Low resistance.
Not an open bulb,
Short.
but there's no resistance there. If you turn it on, it's gonna blow the circuit breaker. So this 0 to 40, that's not correct. You might get an infinity reading for 40, and that's if the light switch is on or off when you're doing the test from the board. But in this case here, 0 to 40 is not a good, that's from the factory 0 to 40, that's not good. It has to have some resistance. You cannot apply voltage to any load that is 0 ohms.
Yeah, but that right there, that's from the factory, this, diagram.
And there's a
right?
mistake with that diagram.
Yeah.
And I have a couple of
Yeah, when
videos.
I went through it yesterday for you, I seen it, but I'm like, okay.
Yeah, but I have a video on a GE stove. It's on YouTube. where the manufacturer drew a direct short on the control board. And I drew the right way how it goes.
And he had a 0?
No, if you looked at the way it was drawn, line 1 went right to neutral. It didn't have any load in between. It was a direct short. And I redrew the diagram in the video and said, this is the way it's supposed to go, and I showed you the before and after. So watch that video, it's really good on the circuits. Okay, part 5, circuit trace. Trace the bake element circuit, and I sort of did that for you guys just a little while ago.
Black,
To the
L1.
We go into
K4,
connector 2-4, we go through K4 to the bake element, we come here to red, go back to the DLB and go out line 2.
yeah.
Okay? That was easy. Create 2 technical questions about the diagram. So, did any of you guys create some questions for me? Yes, sir.
I don't like it.
That's not a question.
This sucks, so, I mean, hold on.
For him, question for him.
Not interested.
Actually, what I was trying to get out of with you, and I don't think it was written properly, but it's like I wrote all these questions. I want you to know the resistance. I want you to know the wattage. I want you to know the relays. I want you to know the parts. I wanted you guys to come up with questions like as if I was asking you the question. That's what I was trying to get out of it. So I'm really not going to push that part, but it's something in my head because I want you guys to think technically. You're a technician now. You're not, people come off the street. I don't care if you're the newest person in this class, but there's things in here you know already that if someone come off the street right now, they don't know what you know. So you're already becoming a technician. Now, whether you're a real great technician or not, we'll see at the end of the class. But you guys are technicians now. I want you to think that way. Even when you're not here, like Paul and I were working on a microwave the other day, and this was running when it wasn't supposed to be running. And I just looked at the diagram and said, well, this and that, there's no way this could happen if I disconnect this switch. There's no way that fan can run. In other words, I could look at the diagram and tell you how parts operate and run just by looking at, these lines. Yes, sir.
Okay, I got a question.
Okay.
The oven we were working on, the decor,
Don't tell me about that stupid fan that we're dealing with, but go ahead.
well, it's gonna relate to it, but, so the sensor checks out with ohms, the elements, both bake and broil, check out with ohms on both lower and upper. All the relays for the bake, the broil, convection on both lower and upper are working.
Mm-hmm.
And what would your final diagnosis be? Other
With
than,
that fan?
No, with the reason why it's showing the error code for the oven temperature sensor.
Well, oven temperature sensor error code is the board always is checking the sensor. It's always setting a little voltage. When you first turn it on, the oven's cycling and you turn it off. The board is not taking what it's checking on the sensor, whether or not elements work or not. So the first thing it does when you turn it on, it's looking for that 1,000 ohm range, roughly. Okay? If it reads 0 or infinity, it's going to tell you it's got a shorted or an open sensor. Okay? It doesn't know if the bake element's working or not. It doesn't know if the broil element's working or not. It knows, turn the relay on for the bake to work, but it's not measuring current flow through the board to say, aha, that element is working properly. So if you had an error code saying something is wrong with your sensor, then you would start off just like we said at the beginning of the sensors. We're going to disconnect it from the board and see if we get a resistance value. Now what happens if you got an F3 error saying the sensor's bad? I unplug that plug from the board and I touch the 2 terminals that are going down to the sensor and I get 1,050 ohms.
Sensor's bad.
You guys agree with that?
Oh, the sensor sounds like.
No.
The
Fuse.
sensor's
You
good.
going down?
Then what do you think?
The fuse is good,
Okay, but the board's saying it's bad.
It's bad.
but it's reading.
It's reading good though, right?
Yeah.
Bad
So
board.
cut in the line?
It's a bad board.
Bad board.
Very good, Corey. So the board, even though the sensor resistance value is good, the board don't see it. Something on the board got messed up and it can't see it.
Can you, alright, so if the board doesn't recognize it, just like any other board you can do, can you
Bypass.
jump in and bypass it to see if it
Not
works?
an oven sensor, you could jump a relay on the board to send power to a load like an element or a motor.
Okay.
But a sensor you can't jump because the board needs
Feeds,
a resistance value.
To
And
feed
if the
it back.
plug you unplug is telling you the resistance value going down to the sensor is good, that's the one thing. If the board's telling you something is bad, you got a shorted element. You unplug and test the element checks good, and you check it from the board,
Yeah, the board is bad.
then the board's bad.
It's not recognizing.
Once you prove that it says this part's not working right, but the part is working right, then the board is bad. The board's not seeing it. It's not cycling it like it's supposed to. Okay? I'm not gonna go over these today. I'll save this half for tomorrow, because I know some of you guys, it's already 10 o'clock. We'll do the second half of this tomorrow.
thank you.
I plan on only going until 10 o'clock tonight. Anybody got any questions about